Today we're looking at Lesson 3.2, Solving Inequalities. Our learning targets are still writing inequalities to represent real-world situations and sometimes solving multi-step inequalities. Let's look at number 1. Make sense of the problems. Chloe and Charlie are taking a trip to the pet store to buy some things for their new puppy. They know that they need a bag of food that costs $7 and they also want to buy some new toys for the puppy. They find a bargain barrel containing toys that cost $2 each. Write an expression for the amount of money they will spend if the number of toys they buy is T. And so we go in, we look at our numbers that they give us. They know that they have to buy a bag of food that's $7. We know that 7 is going to be part of the expression. And they also want to buy some toys, which we are $2 each, and we're designating those toys with the letter T. So it's going to be 2 times the number of toys that we buy plus the $7 for our dog food. 2T plus 7. Part B, Chloe has $30 and Charlie has 1/3 of this amount with him, which is $10. Use this information and the expression you wrote in Part A to write an inequality for finding the number of toys they can buy. So we'll say 2T plus 7, okay, has to be less than. They have to spend this much money less than what they have, which is $30 plus 1/3 of $30. So 2T plus 7, that's our expression, is going to be less than, we might can change this to less than or equal. We'll use this little tool here. Less than or equal to 30 plus 1/3 of 30. And we can simplify that to 2T plus 7 is less than or equal to we had said that 1/3 of 30 was $10 and 30 and 10 is 40. Also remember that you could write this as the other direction as long as 40 is greater than or equal to 2T. Oop, there it goes, 2T plus 7. Either one of these is fine. There are different methods for solving the inequality you wrote in the previous question. Chloe suggests they guess and check to find the number of new toys they could buy. Use Chloe's suggestion to find the number of new puppy toys that Chloe and Charlie can buy with their combined money. And you can do this by saying maybe they'll buy, let's say, first 10 toys. And we need this number to be less than or equal to 40 for them to have enough money to buy it. We're just guessing and checking. 2 times 10 is 20. 20 plus 7 is 27. So we know that 10 toys, they can afford that. All right, let's try 15. 2 times 15 plus 7. 2 times 15 is 30. And 30 plus 7 is 37. They have enough money for that. That's still less than or equal to 40. We could keep going. We could try 16 because we are getting pretty close. 2 times 16 plus 7. That would be 2 times 16 is 32 plus 7 would be 39. I think if we added one more $2 to it, it would go over 41. So 16 would be the very most that we could do just by guessing and checking, starting with 10, going to 15, 16, working our way around the numbers. We could have also gone over. We could have said 20 and known that we had to go less than that when we found out that it would have been more than $40. But that's the guess and check method. It's just trying numbers until you can get to one that makes the most sense. It does take a little bit longer to do it that way, though, which is why we're trying to learn how to solve our inequalities. Charlie remembered that they could use algebra to solve inequalities. He imagined that the inequality symbol was an equal sign, and that is what we do. We do treat inequality symbols as equal sign. We can know that they mean slightly different things, but we treat them as the same way. Just like we know that the variables are not like our constant numbers, but we usually treat them the same way. So using Charlie's method to solve the inequality, we wrote in item B. So that's 2t plus 7 is less than or equal to 40. We want to do the same thing that we did in our previous lessons, move everything around so that eventually t is by itself. So I would have 2t. I would want to get rid of the 7, adding 7 by subtracting 7 to both sides. Like this. This would leave me with just 2 times t is less than or equal to 40 minus 7, which is 33. And then we're going to divide both sides by 2 to get rid of the 2 that is being multiplied times t. Like so. And so we'll have 33 divided by 2 on this side. 2 divided by 2 is just 1, which is just 1t. It's going to be less than or equal to 33 divided by 2. Or 2 goes into 33 16 times, and you'll have 1 left over. 1 half, 16 and 1 half. Either one of these would be fine. Did you get the same answer using Charlie's method as you did using Chloe's method and explain? We got a more precise answer here because we were able to keep up with our fractions and decimals than we were just guessing. I mean, we could have guessed like the change that would use like $16.50 probably, but right now using our algebra, we were able to quickly is the key, get a more precise measurement. Using algebra. So number 5 says, how would you graph a solution to Charlie and Chloe's inequality? Well, we come to this little Desmos calculator. We'll say, well, it's less than or equal to 16 and a half. So we're going to say x is less than or equal to 16.5, 16 and a half. And you'll see that they graph it for you. And you can see on this line, 16.50 on the line, it's a solid dot and it covers everything less than that. You can see, zoom in and see 16 and a half, 1 past 15 and then half more. And it's everything less than that is covered for 16 and a half. All right, Jaden solved an inequality as shown below. Describe and correct any errors in his work for number 6. Well, let's look at it. 3x plus 5 plus 6x is greater than 23. Okay. 9x plus 5. So let's see what he did. He said 3x plus 6x is 9x. That's fine. Good so far. He then needed to move his 5 over here, and that is where he went wrong. He got rid of this 5 by subtracting it, but he added it over here. He just moved it across. He didn't actually subtract 5 from both sides. So that is where he went wrong. Jaden didn't use the subtraction equality property properly. He should have gotten 9x is greater than 23 minus 5, which is 18. So that's where he went wrong. You can just look. It's plus 5. To get rid of it, you need to minus 5. But you also need to do the same thing over here for our subtraction property of equality that we learned in the last series of lessons. Chloe liked the fact that Charlie's method for solving inequalities did not involve guess or check, and so she asked him to show her the method for solving for this inequality. Negative 2x minus 4 is greater than 8. Charlie showed his work below. When Chloe went back to check the solution by substituting a value for x back into the original quantity, she found that something was wrong. Okay? She found something was wrong. So let's see if Chloe did anything, Charlie did anything wrong that Chloe found a mistake, or if Chloe made a mistake and did anything wrong. So we have this, and then they added 4 to both sides. That's right. Okay. They divided by negative 2. I see where they went wrong on this one. They did not change this sign. When you divide or multiply by a negative on inequalities, the sign needs to change along with it. So that is where she went wrong here. And we're going to say that Charlie did not change the inequality sign when using the division property of equality with a negative. Chloe tried the problem again, but used a few different steps. Okay, so let's see what she did. She subtracted 2x from both sides. Okay, it's not multiplying and dividing, that's fine. So she said she added 2x, I'm sorry, not subtracted. She added 2x to both sides. Again, fine, because you're not multiplying and dividing by a negative. And you're left with negative 4 equals 8 plus 2x. She then subtracted 8 from both sides to get rid of that one. She's left with 2x equals negative 12. Okay, so far so good. Then she divided both sides by 2 to get the x by itself. So far so good. She is correct. She did everything right. She didn't have to flip the signs because she did all of her moving with adding and subtracting instead of waiting to the end. So that's fine. She got it right. She is correct. Explain what Chloe did to solve the equality. Well, she used her, let me type it. She used only addition / subtraction equality properties with negatives. So she didn't have to change the sign. And she used her division with a positive, so that's You can keep the sign when you do that. Number 10, Charlie looked back at the work. He said that he could easily fix his work by switching the inequality sign. That is true. That's okay. If he goes back and fixes it, he would just need to switch this sign right here to make it less than sign. Almost all these methods work. Charlie and Chloe wanted to know why they were working. Here's an experiment to discover what went with Charlie's first method. Look at what happens when you multiply or divide by a negative number. So you pick two different numbers, 2 and 4. 2 is less than 4. That's okay. Multiply both of them by 3. 2 times 3 is 6. 4 times 3 is 12. That's fine. It's still less than that. Multiply both by negative 3. 2 times negative 3 is negative 6. 4 times negative 3 is negative 12. Now we need to flip the sign because of the negative sign, because when you're dealing with negatives, it works in the opposite way, that the closer you are to 0, the bigger your value is on the negative side. So, and the farther away you're from 0, the less you're worth. So negative 12 is less than negative 6. And so that is one of the reasons we need to flip the sign when multiplying or dividing by a negative. 2 divided by 2 is 1. 4 divided by 2 is 2. 1 is less than 2. That's okay. 2 divided by negative 2 is negative 1. 4 divided by negative 2 is negative 2. Negative 2 is less than negative 1, or negative 1 is greater than negative 2. That does make sense. We did have to flip the sign. Same reasons. Negative 1 is closer to 0 than negative 2. It is worth more. So just kind of keep this in your head when you're dealing with inequality signs and multiplying or dividing by negative numbers. That sign needs to change in order to keep it making sense. All right, they have an example here of how to graph and solve this equation. They solve it using the same methods that we've been using solving equations. They move everything to one side. They get it by itself. Okay, then they graph it. Look at the sign. It is greater than or equal to negative 5. So when it has that little line underneath it for greater than or equal, we put a solid dot on negative 5, and it is greater, so it is getting bigger. It covers the side of the number line that are larger numbers than negative 5. So this is a very good picture to show you what it looks like when you graph it. We will do this one. So let's solve it first. We want the x by itself, so I will start with what they have. 3 minus 4x is less than or equal to 11. And then I will say, well, I want to get rid of this 3 in front, so we will do minus 3 plus 3 minus 4x is greater than or equal. Find my greater than or equal to sign, or less than or equal, I'm sorry. Less than or equal to 11, and I have to do my subtraction inequality minus 3 to keep it equal. This becomes 0, so that's negative 4x is less than or equal to 11 minus 3 is 8. Okay, I need to divide, so negative 4x divided by 4 is going to be negative 4, hold on just a second. Okay, and I need to flip the sign when I do this. Since I'm dividing both sides by a negative, it's going to be now greater than or equal to 8 divided by negative 4. I flip the sign when I'm dividing by a negative or multiplying by a negative. And that'll leave me with x is greater than or equal to 8 divided by negative 4 is negative 2. So that is the solving part. Now let's graph it. We'll go to our Desmos calculator, our graphing calculator. We will say x is greater than or equal to -2. We'll zoom in so we can see it. And you'll see that it's a solid dot, and it covers everything that is greater than or equal, since that's the solid dot part, greater than or equal to -2. Okay, we can just do this on our Desmos calculator, or you could hand draw it if you have your book and draw in the number line like this one. Okay, this is just a little bit harder to do on the computer if you're not doing it by hand. So we just use this calculator to kind of help us show us what it would look like. It's kind of, all right. So I want you to try 14. Okay, just tell me what inequality could this represent. It says two different inequalities that this solution represents. You just kind of need to write it two different ways. Same value, but you can write it in two different ways. And then try and solve 16 through, let's just say 20 for right now. 16 through 20. Do those, and that'll be that for this lesson, I believe.